Hello students, today we'll start with module 5, network security and application. So whenever we are talking in terms of the network security, so very first thing that comes in our mind is the internet. And as we all know that internet itself can be considered as a computer network. So we need to talk in terms of the network security only in this entire module. But before that, if I ask you that what is the importance of internet in your day-to-day life, so everyone will say that the use and importance of the internet is unquestionable. Like we can't live without the internet, right? Because if you know, then there are currently over 4.33 billion active internet users worldwide, and 57% of the entire world population has the internet access. Means billions of users are using the internet for some or the other purpose, for getting some information and interacting through the different applications. So we need to route all these internet traffic to the correct place directly. Or this online data must know where exactly it is going, where exactly how it is going to communicate. So this is where your first concept of the network security will comes into, which is called it as your transmission control protocol and the internet protocol suite, or the stack, that is your TCP IP stack. So in today's lecture, we'll just see what is the TCP IP protocol suite or the stack, and what are the different layers in that stack, and how those different layers will help you to understand where that online data is actually going. So you can consider the TCP IP in terms of as a cake or a sandwich. But these cake or sandwich, like they are made up of a different layer. Similar way, the TCP IP protocol suite is made up of a different layers, and these layers are made up of what? The computer codes. So like you can say here, what are the different layers over here that are conceptualized? That is application, transport, internet, and the network layer. So TCP IP protocol should consist of total 4 layers. So the very first layer, that is the topmost layer, is the application layer. So this is where your program, like your web browser, directly going to interact with in terms of the data. So the different protocols used over here are what? The HTTP, then your SMTP and FTP, based on the different application or the program that you are using. Then the next we have is the transport layer. So in transport layer, we have the protocol TCP, which lives along with the UDP, that is your user datagram program, which is faster and bit useful for the legacy application like your online games. Now, after the application layer gets the data from whatever the program that you are using it, either it is mailing, either it is web browser, either it is FTP program. After this, what it do? It talks with the transport layer. So how it is going to communicate with the transport layer? So it's going to communicate with the transport layer with something called it as a port. And this each and every port can be assigned to the different protocol, as you can see in this diagram, so that the TCP knows from where actually the data is coming from which port. As the ports are assigned to the different protocol, TCP gets to know that from where exactly the data is coming from. For example, most of the activity in your web browser are getting through the port 80, which is HTTP always uses. So now transport layer get to know that your data is coming from where? From port 80, that is HTTP, means the application is your web browser or the website request, that it will get to know. Now, after it is connected to the transport layer, what transport layer? In transport layer, we have TCP. So what TCP does when it gets the data, it simply chops into, or it simply segment into the different chunks, that is called it as a packet. And these packets dispose individually, and then it will take the quickest route over the internet to get wherever they wanted to go. So in TCP, simply what happens, whatever the data received from the application layer, it is going to divide into the packets, or you can say it as a segment or the small chunks. And after this TCP divided that entire data into the different packets, but now it wanted to know whether at the receiver side the receiver computer are receiving this packet into the same direction as it has sent, because all these packets are not going in a sequential order, right? They can be go in a different order. So this TCP wanted to make sure that the receiving computer should get all those packets in the same direction, so that it can reassemble and it can get back the original data that he has sent. So for that reason, what TCP is doing, so the TCP is adding the TCP is adding the header to each and every packet. And what that header contains, the instruction or the order or the sequence number in which this order need to be reassembled at the receiver end. So that TCP header will be added, so that the receiver will again arrange or reassemble all those packets into that same order. And after this is done, now the packets are pushed where? Onto the next layer. So that next layer is nothing but your internet layer. So what happens over here? This internet layer chooses the protocol, which is that protocol, internet protocol, which is going to attach origin and destination IP address. So the packet knows where it comes from and where it is actually going. And after this, when it attached the origin and destination IP address, now the data is sent to the next layer, that is the final layer. And what it's going to do, it's going to handle the data like MAC address, so that packet gets to know the right physical machine address, and finally it gets delivered. So this is exactly your TCP IP protocol. TCP IP protocol works, and the different layers in that TCP IP protocol works in short. So finally, how we can conclude that your TCP deals with what? TCP deals with ensuring that the data packets are delivered in a reliable manner. When we say reliable manner means what? That the sender TCP always know whether or not a packet is reached to the receiver TCP. Means that acknowledgement can be done in the TCP. And what IP do, that is your internet protocol, it simply deals with the routing of packets of data from one computer to the another computer. And if you can see in terms of the connectivity, your network connectivity, when you are connected with the internet, you can see such window. And in that window, if you check on the properties, networking properties, so you can see you are connected with the TCP IP, you are connected with the TCP IP protocol suite. So it may be your IP version 4 or 6, the header format that are connected with. And as you can read over here in the description, this TCP IP, the default WAN, that is your wide area protocol, that provides communication across the diverse interconnected network. So if you want to understand in terms of the example that how the TCP IP protocol works, so consider an example over here, that this is Mr. XYZ. Consider he is a writer, and he is writing something on his computer. So what he is writing, let's say he is writing over one manuscript which he need to send it to the editor for publication. Now we'll just see what happens when this manuscript goes through the different layers of this protocol, TCP IP protocol suite. So the manuscript he is writing, that is nothing but what? Considered as a data in the application layer. So that data or that manuscript is very large. So what we are going to do, that large data or that manuscript, we are going to divide into the different segments. And the segments are nothing but what? Packets. And that packet constitute where? In the transport layer. So these segments are nothing but what? Your transport layer. Transport layer will going to handle this each and every segment. So to this each and every segment, what we are going to add? We are going to add the transport header. Why transport header? Like I told you, in order to get to know whether the receiving computer will get all the packet or all the segment into the same direction, that is in order state, we need to add this transport header. So what consists of this transport header? It consists of the port number, right? It consists of your sequence number, which are attached to each and every segment. After the transport header added, the next header is what? The next layer you can see is the internet header. So internet header, what will be there? This segment ka IP address and the destination IP address, both will be attached in this internet header. So that particular packet gets to know where it has come from and where it is going. And then the last header that we are adding over here is what? That is the network access header, where the actual physical machine address is provided, like your MAC address. And here the network access trailer is optional, just for the error checking purpose. So this entire process or the entire headers are attached to each and every packet that are traveling over the internet. And this entire process is called it as your encapsulation. Encapsulation is nothing but what? Each layer adds a header and an optional trailer to the information from the preceding layer. So in this way, a data is being preceded and succeeded by a number of header at the different layer, and finally it reaches to your destination. So this is actually your TCP IP protocol suite work, starting with your application, then your transport, then your internet, and finally to the network layer. So this we have studied about the TCP IP protocol suite. Now in this module we need to understand what are the different vulnerabilities in these different layers. So in order to understand those vulnerabilities, first we need to know how the TCP IP protocol works. So I think with this video you have clear about how the TCP IP works. So in the next video we'll learn about what are the different vulnerabilities in each and every layer, and what are the different attacks which are possible on these layers. Thank you.